So welcome you all in iitiansgateclasses and myself Dinesh. I am organizer come chief mentor at IGC. So in today's session we'll be discussing about strength of material, and in strength of material we'll be discussing about shear force bending moment diagram, and this is a demo class, okay, for our Feb and May batch as well as July batch student. So guys, be free to ask if any question you guys have, and let's make this session as interactive as possible. Okay. So guys, this today's is a class about strength of material, and in strength of material, shear force bending moment diagram is a topic. And guys, this shear force bending moment diagram is very important topic in strength of material you call aircraft structures basics. Okay, everywhere this subject is very important. Okay. Okay. So, guys, first I want to know about uh, what is beam. Okay, when you call a slender structure as a beam structure. Okay, and what is the purpose of drawing shear force bending moment diagram? Okay, so guys, can anyone tell what is a slender structure? What is a slender structure? What is a slender structure? Anyone? So guys, those who are watching this session on YT, am I audible? Can respond guys in chat box. Negligible thickness, thin? No. A slender structure is a structure when length of structure is large or more than other dimensions is known as slender structure, right? You guys know, right? Well, usually you guys draw a bar or rod. So it's what a long prismatic structure where the length of structure is very large compared to other dimension, or you can say in this slender structure your length is much higher than other dimensions. Other dimensions is what you can say, width and depth or thickness. Clear guys? So when a structure is known as slender structure, if the length of the structure is very high compared to other dimension, okay, so it is known as slender structure, and this would be a prismatic structure. What is a prismatic structure? Can anyone tell what is a prismatic structure? What is a prismatic structure? Not Mohit, a slender structure is a tapered shape. Okay, prismatic. What is a prismatic structure? If the cross section of the entire length remains same, the cross section of the this entire length remains same, the cross section is same throughout length, then the or uniform cross section throughout length, then structure is prismatic. What is another condition apart from uniform cross section for prismatics? structure? Can anyone tell? So first is uniform cross section. Another, yeah, EI is constant, or you can say material. Material properties is uniform. Okay, so your material is what? Is uniform material or elastic material, right? So the material should be homogeneous, okay, or uniform. Okay, there should not be impurity of the material. Then only it will be a prismatic structure. So these are the condition. So material, uniform cross section, and also homogeneous material. Now guys, tell me further. You guys understood what is a slender structure? Now this slender structure is known as bar or rod van, and this same slender structure is known as what? Shaft van, or this same slender structure is known as beam. Because in today's class we are going to discuss about what? Shear force bending moment diagram. And for what kind of structure we draw shear force bending moment diagram, guys? Anyone? Mohit, can you tell? When this slender structure is known as bar or rod or shaft or beam, in which case or on what basis? The same structure behave like bar or rod, or behave like shaft, or behave like beam. On what basis? Anyone? No, it is not based on support. Arkashjit, when we call, exactly, Shabri is very good. Not just transverse load, it's purely based on load. So the classification is based on what? Applied load. The way you applied load, it may behave in a particular way. Okay, it is completely based on what? Applied load. Now guys, in case of bar or rod, what kind of the load you apply? In case of bar or rod, what kind of load you apply? Axial load. Yes, very good. In case of shaft, what kind of load you apply? Twist or torque or torsional load. In case of beam, what kind of load you apply? Buckling load you apply. Lloyd? Longitudinal load you apply in case of beam. Torsional load you apply. In case of beam, we classify load as what? Transverse load. Okay? Or bending moment. Like point, UVL, UDL, these are the transverse load. Okay? You need to classify as a transverse load. So if on this slender structure, if your load is axial load, then this is known as what? Then this is known as what? Mohit, it can be a point load, it can be a UDL, it can be UVL, it can be a bending moment. Okay. So if the load is axial, then it is known as bar or rod. If applied load is what? So I can draw and show, guys. If you have this slender structure and if load is axial load. Now axial load can be what? It can be a tensile or it can be what? Or it can be a compressive load, right? Then it is known as bar or rod. Now what is the difference between bar and rod? Can anyone tell? Hey, Mohit, is it always necessary to be compressive load? Is it necessary to be compressive load for? No. In case of bar or rod, it can be either tensile or compressive load. Okay. Now, what is the difference between bar and rod? Hmm? What is the difference between bar or rod? It's a simple difference, right? It's cross section. Just yes, good. So rod is always what? A circular cross section. Okay, a circular cross section, and bar can have any cross section. That is what the basic difference. Okay, so this is what your bar or rod based on axial load. Axial load. Now guys, when this slender structure is known as shaft, if you have torsional load. Okay, if you have torsional load. Now guys, tell me, torsional loads are applied about which axis? Can anybody tell? Torsional loads are applied about which axis? What is z axis? I have not defined any axis here. Exactly, Kaushik. It is along length axis or it is called as longitudinal axis. So this axis is known as what? Longitudinal axis. So always your torsional load will be applied what? About longitudinal axis. Now the torsional load you can mention by double arrow. You can show by the double arrow. Now this double arrow is going away from cross section. So that means what? If you look from here, it is what? It is this kind of load, right? Torsional load. Clear? Now guys, suppose this torsion or what couple, if this couple is not applied about longitudinal axis, then it is known as what? Huh? Shraddha? Shraddha, if this couple, okay, because basically torque is what? A couple, right? If this is not applied about longitudinal axis, then this is known as what? It is known as eccentric. What I mean, see this slender structure, suppose is what? Circular, right? So if it is circular, then other than longitudinal axis, it will have cross-sectional axis. Just I am showing this is my cross-sectional axis. Somebody told z axis, so I'm considering okay, longitudinal axis is z axis, and this is what my x and y. Now, if this couple is applied about x or y axis, like this, I'm not bothering as of now. As of now, the direction, but I am just writing like this. These are double arrow. So double arrow denotes what? A couple or moment. So if your this couple is applied about x and y axis, then it is known as what? Is it torque? Anyone? Mohit, it is known as what? Priyanka, it is known as what? Is it shear? Is shear is a moment? This is double arrow means it's a moment, right? So what moment? Is it twisting couple? Abhi, Varun, these are simple basics. Very good. Bhavesh, Bhavika. Yes, Priyanka. It's a bending moment. It's a bending moment. So, guys, you are understanding what is the difference between torsion or torque and bending moment. Both are couple. This torque and bending moment. Both are what? Couple. I will explain what is couple also. Both are couple. Okay? You guys understand what I mean by couple? Couple means suppose you have this cross section and if you apply loads like this, what it is going to do? It will create a couple, right? Yes or no? Right? So this is what? A torque. Same way, what happens? You have this is about cross section, right? Now this is beam, right? Now on this beam, you can let me draw here. You can apply a point moment, right? A point moment about what? X axis, right? Now usually we apply, right, a point moment at free end, right? Yes or no? So now this point moment is applied about which axis? Hmm? It is about lateral axis, or you can say it is, if you look from cross sectional point of view, it is about x axis, right? So this is more. Now guys, how this can be created? This moment, point moment, how you can create? See, you have axial load. Currently it is passing along what? Longitudinal axis. So when you can create this point moment, can anybody tell? Nirav, when you can create? Patricia, Shabresh, Shatvik, Vaibhav, Uday, Vaishnavi, Saujanya, Satyendra. Equal reaction, no. Point load, no. See, when you can have this point moment at free end, Priyanka, it is very simple. See, currently this point load passing through longitudinal axis. It is applied exactly along the axis. If I do eccentricity, instead of guys, I will draw little bigger. I'll draw little bigger, guys. So initially this axial load is applied along axis, right? Suppose this is P. Now instead of this, what I am doing, it is applied on this circumference. What is going to happen? Priyanka, in this case now what is going to happen? If in second case, this is the first case and this is what? Second case. What is going to happen? Since due to this eccentricity, right? What will happen? When you shift this load to center position, it will be shifted with a point moment, right? So it will be PE, right? So this is how these point moments are generated. And this point moment is nothing but what? It's a bending moment, right? It's about lateral axis. Clear? Now, is this clear, guys? Vishal, is this clear? Shraddha, Mohit, others, is this clear? Okay, so you all understood, guys, right? What is the difference between a torque and bending moment? Torque is always applied about what? Longitudinal axis, and bending moments are always applied about what? Lateral axis. Now your lateral axis can be what? It can be x or it can be y, or it can be applied in a inclined plane, inclined axis also. Clear? Everyone, is this clear? The difference between torque and bending moment, the the difference between, what is the difference between your uh, bar shaft. Now the last case is what? Beam. So how you classify in beam? Either there is a point moment or you can have a point load anywhere on the beam which is transverse load, or you can have what? UDL, or you can have a UVL, or you can have any arbitrary transverse load. Then this structure will behave like a beam. Clear? So then this structure will be beam. Now guys, tell me, in a practical problem, in a real structure, a slender structure will go or will subjected to only axial load in a practical or in a real structure. Is it necessary a slender structure will only subjected to axial load? No. It will usually undergo what? Combined load, right? It will usually undergo what? Combined load. Yes or no? Combined load means what? Combined load means what, guys? It will undergo what? Axial load, transverse load, or it may also subjected to what? Torque. Clear? So that means you need to analyze for each load case. Clear? Axial plus transverse plus twist. Okay? Okay. UVL and UDL. See, UDL means uniformly distributed load. UVL means uniformly varying load. This a triangular loading is known as UVL. UDL means uniformly distributed load. Okay, these are the different kind of load we are going to discuss anyway. Okay, in bending moment, sorry, in first beam, classification of beam also we will discuss. Okay, now guys, the last point which I want to know from you guys, somebody was talking about buckling, right? Somebody wrote somewhere buckling, right? Who wrote buckling? Someone somewhere wrote buckling, right? Yeah. So what is buckling? Where it happens? Buckling happens where? Hmm? It happens in case of column, right? So when this slender structure is known as column, can anyone tell? Huh? Sudden change in shape is what buckling? No, it's not. Vishal, it can have inclined load also. See, you apply inclined load, what you see? You will have two component. One is what? Axial component, and one is what? Transverse component. So that means what? It has what? Axial effect also, axial stress, as well as it will have bending stress. Clear? So it's what? A combined load. Now I am talking, guys, about I'm talking about column. So when a structure is known as column, and who told it is vertical? Why can't it be inclined, horizontal? Huh? It's not necessary, Mr. Arkazit, it has to be vertical. Any slender structure, if it is undergoing compressive load, and structure is what? Very long structure. A prismatic, long, slender structure undergoing what? Compressive axial load may fail in buckling. And if a structure fail in buckling is what? Column structure. Okay. So column means not necessary to be, or I say in other way, a structure need not to be always vertical to fail under buckling. I can have a structure, Mr. Arakji, like this, and it is subjected to compressive load. Okay, it may buckle, it may buckle under, it may fail due to buckling. So tell me, what is buckling? Then anyone can tell what is buckling? It's a Is it a material failure or failure due to strength? Priyanka, is it failure due to strength failure, or you can say other way, yield failure, or a material failure? No, it's not a strength failure, Mr. Harshil. Buckling is not a strength failure. Okay, anyone can tell what kind of failure buckling is? Is it a strength failure, or you yield failure, or something else? Vishal, Mohit, Shraddha. So are you guys understanding whatever I'm discussing? Are you guys finding interesting? Huh? Or I can have a structure. Usually people say a vertical long slender structure is what? Column. Which is wrong, right? People always tell this. Yes or no? All you guys might be learned like that. No. See, failure in structure under high axial compressive stress, no, it's not buckling. Just a moment, guys. Okay, so I will, guys, just tell you all. How many of you have learned strength of material? Just quickly tell me. How many of you have already learned strength of material in your undergraduation? Hmm? So quickly, Varun, Sojanya, Sanjeev Dharan, Nikhil, Mukul, Manju, Het, Deepak, Chahit. It's not a material failure. First, Priyanka, it's not a material failure. Everyone, buckling is not a material failure. Okay. So those who have learned this strength of material or mechanics of material, have anybody used books called Timoshenko Gere or Hibler? Anybody have used books mechanics of material like by Hibler or Gere or Timoshenko Gere? Okay, so those who have used now, go and read buckling chapter. Okay, or if you guys have used then missed the point. Okay, so the buckling failure is due to what? Is always due to external disturbance. What is external disturbances? Can anyone tell? Suppose you have a pillar, okay, and it is subjected to some axial load, and initially it is straight. What can be external disturbance? Can anyone tell? In an atmosphere, you guys have seen the many pillar. What can be the external disturbance? It is an external disturbance. Huh? It is not an external disturbance. It can gust, right? Wind, tufan, right? Tsunami or earthquake, right? So, if you have any external disturbance, what will happen? That external disturbance will do what? It will bend this, right? Suppose it got bended by, it got deflected, or you can say it will deflect, right? So by some angle theta. So what happens if it got deflected by some angle theta? Then what is going to happen further? Hmm? It should come to initial position, yes or no? Right? No, it will not oscillate. It's not dynamic load. I'm not talking about dynamic load. I'm talking only static load. Currently, just static load. What is going to happen after that? Suppose due to this wind or some external disturbance, huh? It got deflected by some angle theta. What happened after that? There are two chances, right? It may come back to original position, or it will be further deflect, right? It may further deflect, right? These two position is possible, right? Yes or no? Clear or not? Right? So when it will come back, when it will come back. So guys, what happens when it deflects? Suppose it got deflected by what? Some deflection, which will be what? If length is L, so this deflection will be what? L theta, right? So this L theta into P is what? This L theta L theta into P is what, guys? The moment created by this P load, right? Now tell me, guys, this L theta into P about this support acts in what? Clockwise or anti-clockwise? It is anti-clockwise, right? So this anti-clockwise moment is disturbing moment or restoring moment? This is dist disturbing moment, right? So mean, if it is a disturbing moment, then there has to be what? There has to be opposite moment, right? There has to be what? Opposite moment, which is called as what? Restoring moment. Okay, so there is what? Distor disturbing moment, right? Dm, which will be what? L theta into P, and there has to be what? One restoring moment. Now guys, tell me, this restoring moment will come from where? From where it will come? It will come from strength of column. Okay, support. Basically support, right? So what we usually do to understand buckling of column, we idealized a column. Okay, this what I am showing now. So column has to be idealized. How we idealized column, guys? This is suppose a column. It can be a vertical or it can be a horizontal slender structure subjected to load P and length L. Now it has to be idealized what? A massless slender structure, or not massless, I should not say, a rigid slender structure with a spring support. Okay, with a spring support K. Okay, and this is P load. Clear? And this is what? Length L. Clear, everyone? Right? We can idealize yes or no. Any structure can be idealized in simple structures, right? This is what? A rigid link with spring, right? And K is what? Stiffness of this column. Clear? Now guys, if you see, when column get deflected due to disturbance by some angle theta, right? And this is what P. So there are two moments, right? First, in this spring, what happened? When it got deflected by L theta, what is going to happen in this spring? There will be a spring force, right? What will be that spring force, guys? Huh? It will be KL theta. Now this KL theta will give me a moment about support what? Restoring or destroying moment? What kind of moment it will give? Exactly, restoring moment, right? Restoring moment. Everybody agree, right? So what will happen when it is a restoring moment, right? So what is your restoring moment by idealization? It is K L square theta, right? This Fs into length. Everybody agree or not? right? So guys, now tell me, when buckling will not happen, or when this slender structure will not fail, if Rm is greater than Dm. Clear? If Rm equal to Dm, what will happen? If Rm equal to Dm, what will happen? So this is known as what? Stable. This condition means your column is stable. In this condition is what? It's a critical condition. Okay? This is what? Critical condition. So what will happen? Neutral position means your column will become stable in new position. It will not come to initial position, but it will be stable in new position. And what happens if Dm greater than Rm? What is going to happen? It's a failure. So Dm greater than Rm means what? From here, what you see, guys, this PL theta greater than what? KL square theta. So what from here? Your P is greater than what? From this, what you find, guys? Your P is greater than what? KL. What is going to happen? For any small disturbance, that disturbance will increase, right? For any small theta, the theta will keep increasing. Then what will happen? Failure will happen. So that is what? Buckling of column. Now is it clear to everyone what actually buckling of column? Right? So that means what? That means what? Yeah, why not? It is possible, Mr. Vishal. In case of fixed beam also, you can have na column with fixed support. Why not? Vishal, you can have na column with different boundary condition. You can have a fixed free column also. Clear, everyone? So buckling is a failure due to external disturbances. If your P is what? If P is greater than what? P critical. So in buckling, in design, you what you say? Buckling load. Design buckling load, right? Everyone, have you guys heard about? In design we use what? P critical. What is the P critical? For a simple Euler-Bernoulli buckling theory, what is the P critical? It is pi square EI by L square, right? So this is what P critical for what? Hinge beam, right? Agree na? Clear now, everyone? If your applied load is greater than P critical, what is going to happen, guys? What is going to happen? Even your strength may be higher. So P critical may give us what? Sigma critical. And this sigma critical can be lesser than sigma yield. But it's still what? Now its recording is happening. Aklesh, don't worry. In your side, you need to refresh. So Vishal, is it clear? Everyone, is it clear? So what is going to happen? If your load is greater than critical load and any disturbance happened either due to wind or maybe due to gust or anything, what is going to happen? Your structure will fail under buckling. Okay, failure will happen, and this P is what? A compressive load, right? It's a compressive load. Okay, so guys, buckling failure is not a material failure. Buckling failure or buckling happen due to external disturbances if your applied loads are higher than critical buckling load. Clear? Everyone, is it clear? So guys, in today's session, I thought to discuss about SFBM diagram, but we ended with discussing all these simple basics, and I think I have consumed my time, today's allotted time. When we take classes, we go in more depth for each and every topic. Okay, so now I will discuss few more things about shear force bending moment diagram, and I want to ask you a simple question. I'm not discussing today about supports or type of beam. I'm simple asking, you have a simply support beam. Those who have learnt this subject already, I'm asking one question guys to you guys. Okay, you have a simply support beam. Okay, usually we draw like this, simply support beam, and it is subjected to a point moment. Now guys, tell me, anyone, this point moment M, those who have already learned this subject, this point moment, suppose it is at mid of the beam only, this length is L and it is applied at mid of the beam. Now right of the this moment and left of the moment, how the bending behavior will be? How bending behavior will be? You guys have heard now sagging and hogging. Those who have learned this subject already, what is the sagging moment? What is the hogging moment? Hmm? Arkajit, what is the sagging? What is the hogging? Lohit, Ponraj, what is sagging? What is hogging? Yeah, it's a mid span point moment. It's not force. It's at mid of the beam, I have applied, or anywhere I can apply a point moment. What is sagging? What is hogging? Okay, suppose a beam is bending like this, then this kind of bending is known as what? On top we have compression and bottom it is tension. So this is known as what? Sagging. This is not cross section guys. This is not cross section. This is along what? Length of the beam. So this is what? Sagging. Okay, this is what guys? Sagging. What is the hogging? If on top of the beam you have tension and bottom of the beam you have compression, this is known as hogging, and this is what? Negative bending moment. Okay, now guys, when there is a point moment, tell me, left of this and right of this, how the behavior will be? In left side, for this point moment, this is what? A clockwise, right? A clockwise point moment. Anybody can tell? Hmm? Lohit. So left side, what you will have? Sagging. You tell, left sagging or hogging? Lohit. Right sagging. Very good. How did you decide it? Hmm? Left hogging right sagging. Very good. Left hogging, right sagging. Good. So how it is decided? So guys, what you do, you just draw the deflection pattern. How the deflection will be? If you see the deflection of this, clear? You can see this clockwise movement. It will press this down and it will press this up. Clear? You guys are understanding? So what happening? The right side undergoing what? Sagging, and this left side undergoing is what? Hogging. Clear everyone? Vishal, is it clear? So those who are watching this session on YT, if finding this session useful, can thumbs up this session. Yeah, Harshit. See what happened when you apply clockwise. This clockwise moment, you try to see what it is doing. It is pushing this beam down, right? And it is pushing this side up, right? Harshil, are you understanding this sense? See, it is like couple, right? You have, see, this is a point, okay, suppose section, and I am applying one load downward here and one upward, right? What it is doing? It will create a moment, right? Like this. So how you see deflection? You will see this is what deflection pattern. So you can now easily make it, right? Your left side is under hogging and right side is under sagging. So this actually very less people understand how we decide the same bending moment. If you come from this side till this, it is positive, or sorry, negative, and from this point to this point it is what? Positive. So now you understood how the same point moment on left side it is behaving as a negative, on right side it is positive. Now guys, again I am giving the same reverse example. You have the same point moment, but now it is acting what? Anti-clockwise. So now tell me, on left and right, what will be the behavior? First tell me, what will be the deflection pattern? So deflection pattern now guys, it will be reverse, right? It is like this. You have a load which is acting up, down, and here up, and about this point you have a couple, right? So this is what? So your left is what? Hogging or sagging? Think and tell answer, Mr. Abhi. Your left is sagging and your right is what? Hogging. Now guys, this is very important. This is very important guys. So those who are watching this session can thumbs up or like this session if finding useful. Okay. So you can see now left side is sagging, right side is hogging. Clear? So guys, this concept is very important in many of the cases when you draw shear force bending moment diagram. Specifically guys, for a simply support beam, and there is a point moment. Now somebody asked draw BM diagram. Somebody asked draw BM diagram. Then it is very important to know. Okay. So guys, with this note, I'll wind up this class. When we start regular classes, we will go in further in depth how to draw, SBM diagrams, and then first before that, different kind of support, different kind of loads, and then different kind of beams, and then the relationship between shear force, bending moment diagram. Yeah, I'm asking guys, can anyone tell what is the relationship between relationship between relationship between SF and BM? Shear force and bending moment. Can anyone tell? What is the relationship between SF and BM? Varun, Vaishnavi, Vaibhav, Saujanya, Shivam, Shabrish, Ranjit, Priyanka, Mukul, Mohit, Kaushik, Vishal. Hmm? Well, I'm asking relationship. You are telling both acting in lateral plane. Okay, so guys, shear force you can denote by V or F. So your shear force usually we denote by V. V is given as what? Dm by dx. The rate of change of bending moment gives us what? Shear force. So now guys, tell me if M is constant, what is shear force? You have a cantilever beam with a point moment. What will be shear force? V will be 0. Right? Clear? Now guys, suppose you have a point load P. So what is your shear force? Maximum, huh? V is what? P. So what will be M? What will be M? M is Px, right? We know, right? At any section, what is your bending moment? It will be P into X, right? So guys, if you substitute in this formula, you can get V equal to P, right? So that's just I told. We should know what is the relationship between shear force and bending moment mathematically, right? And then we can always find one quantity from other. Okay. So that's all for today's class. Thank you guys for listening me for today's class, and if you guys have any further query, you guys can reach on our contact number, our call on this number. You guys can write mail to us. Can guys, you guys can visit our website for IGC courses, and you guys can follow us on different social media platform for more updates.